Okay, guys, so this is the next type of reaction we're going to talk about is decomposition reactions. So the word decomposition means to break down. So when we're talking about decomposition reactions, they're pretty easy to recognize because they only have one thing on the left-hand side. So a decomposition reaction usually breaks down by heat or electrolysis. So the important part about it is to identify what the back group is that you're looking at, okay? So the first one we're gonna look at is decomposition of a metallic carbonate. So a carbonate is CO3 with a -2 charge. So all these examples right here are gonna look exactly the same. So a metallic carbonate breaks down into a metallic oxide plus carbon dioxide. Okay, so I'm just going to write up the problem real quick. Okay, so I'm going to follow the format. So the metal in this case is going to be calcium. So it's going to break down into metallic oxide, so calcium plus oxygen. Okay, a metallic oxide like that. And there's no need to crisscross because they're equal and opposite charges, plus carbon dioxide. Carbon dioxide, CO2. Okay, and we're going to go through and make sure this thing's balanced. So 3 oxygens, 1 carbon, 1 carbon, 1 calcium, 1 calcium. It's balanced. Okay, now I'm going to follow the same format. I know it's going to follow this format because it ends in CO3. Okay, so it's going to break down into a metallic oxide. So Na has a +1 charge. Oxygen has a -2 charge. We crisscross. Plus CO2. So 2 NAs, 2 NAs, 1 C, 1 C, 3 oxygens, 3 oxygens. It's balanced. We just go through and write 1, 1, and 1. Okay. Barium carbonate. Okay, so barium is Ba, has a +2 charge. Carbonate is CO3 with a -2 charge. Now, it's going to break down into a metallic oxide, so barium and oxygen. They have equal and opposite charges, so we don't need to crisscross, plus CO2. And we're going to go look and make sure it balances. 1 Ba, 1 Ba, 1 C, 1 C, 3 oxygens, 3 oxygens. And it's balanced. Okay. Next example is going to be dealing with the decomposition of metallic hydroxide. So a hydroxide is this ion right here. So all of these examples are going to end in OH. So if it ends in CO3, you're going to follow this example. If it ends in OH, you're going to follow this example. Okay, so a metallic hydroxide breaks down into a metallic oxide plus water. So this one ends in OH, so we're going to follow this format. The metal in this case is calcium oxide. They're equal and opposite charges, so we don't need to crisscross, plus H2O. Okay, now you get 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens, 1 calcium, 1 calcium. It's balanced. Next example, sodium hydroxide. Okay, we're going to follow these rules because it ends in OH. So sodium has a charge of +1, sodium oxide breaks down to a metallic oxide plus water. Okay, so making sure this thing's balanced, 2 NAs, I need 2 NAs on this side. 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens. It's balanced. Okay, the last example. Cobalt has a +3 charge in this case because it gives it to us. It's a transition metal. OH has a -1 charge. Okay, so a metallic hydroxide breaks down into a metallic oxide, so CO with a +3 charge, oxygen with a -2 charge. We crisscross, plus water. Okay, now this one's going to be a little bit trickier to balance, so I would start with cobalt first. We got 2 cobalts on this side, 2 cobalts on this side. That's going to change your oxygens to 6. So I have 3 right here. I need to put 3 right here to get 6 total. 6 hydrogens, 6 hydrogens, and it's balanced. Okay, on to the next page of the notes. Decomposition of metallic chlorates. Okay, a chlorate is ClO3 with a -1 charge, so we're going to follow the format for this one. I forgot to write the format in this note, so I will update that. I'm just going to write it in for now. A metallic chlorate breaks down into a metallic chloride plus oxygen. Okay, so I will update that in the file on the notes. That way you'll actually have it whenever you're watching this video. Okay, so I know it's a chlorate because the ClO3, it ends in ClO3. So I'm going to say KClO3. It's going to break down to a metallic chloride. So the metal in this case is K. Has a +1 charge. Chloride is -1 charge, plus O2. Now, the least common multiple between 3 and 2 is 6. So I'm going to put 2 here. 2 Ks, 2 Ks, 2 Cls, 2 Cls, and it'll be balanced. CaClO3, 2. Okay, so a metallic chlorate is going to break down to a metallic chloride. So calcium's the metal. Chloride is Cl with a -1 charge. We crisscross. We bring the 2 down here, the 1 over here, plus oxygen, O2. Now we go to balance this. We got 6 oxygens right here. 6 oxygens need to go right there. 2 Cls, 2 Cls, 1 Ca, 1 Ca, and it'll be balanced. And the last example in this section. Iron 3 chlorate. Iron has a +3 charge in this case. Chlorate is ClO3 with a -1 charge. So we crisscross. A metallic chlorate breaks down into a metallic chloride, FeCl. This has a +3 charge. This has a -1 charge. And we crisscross like that. Plus oxygen. Okay, now let's see how this is going to work out. Okay, so I believe this is a little bit tricky one. So I need 3 Cls. I think we're going to have to double. Yeah, I think we're going to have to double everything right here. So we're going to do 2 Fe's, 2 Fe's. Okay, that's going to change your chlorines to 6. 2 times 3 gives you the 6. 3 times 3 is 9. 9 times 2 is 18. So I need to get 9 on this side. Okay, that was a little bit trickier one. I just made up some random examples. So they might not balance the easiest the first time. Okay, so miscellaneous reactions that break down into individual elements. Okay, so what it pretty much says is that if you have a compound, it's going to break down into its elements. So in this example, the 2 elements are going to be mercury and oxygen. So whenever you split that compound up, it's going to form mercury by itself, and oxygen by itself. Now, we got to balance this. So we got 2 oxygens on this side, 2 oxygens on this side, 2 HGs, 2 HGs. Water. The 2 elements that are in water are hydrogen and oxygen. So, hydrogen and oxygen. Remember that those are 2 diatomic molecules. Okay, now we're going to balance it. So, I need 2 oxygens here. I need to get 2 oxygens on this side. That changes hydrogens to 4, so I need to put a 2 right here. And go through and put 1s. And then sodium chloride. Sodium is Na, chloride is Cl with a -1 charge. So an ionic compound, when it forms, is going to break down into its individual elements. So individual elements are Na and Cl2. Okay, so we go to balance this. You got 2 Cl's on this side. I need to put 2 Cl's on this side. 2 NAs, 2 NAs, and it should be balanced. Okay, I know this is getting a little more complicated. I believe that the first 2 sections are the hardest sections to kind of understand. So that's why I broke them down individually. I'll make sure and make this correction to your note packet before you see this video. And hopefully this isn't too bad for you guys. And if I need to re-explain something, please feel free to reach out. Hopefully you'll have a good evening. Thanks. Bye.